pump we're talking about is a Bingham HPD. It's a 20-stage vertical pump that is in a hydrotest application for a steel mill here in Colorado. As the mill produces new oil field pipes, the pipes have to be hydrotested. So that process involves using this pump to fill those up with water. It comes to pressure for roughly 15 to 20 seconds to hold that pressure, and as long as the pressure holds, and that piece of a pipe is actually accepted and moved further down in their manufacturing process. It's a very tough process on the pump. It actually goes from full pressure to a reduced pressure repeatedly over the course of the day, so it's very tough on the equipment. So this pump, it was originally manufactured in the mid-1950s, and it's made of cast iron, as were most pumps at that time. One of the things that's proved difficult over the years is as this pump has worn, is welding the cast iron casing to reclaim the fits and bring that back to correct clearances. That process in the past has involved bronze, so you weld in a lot of bronze which can actually bond to the base cast iron material. But the last time we repaired it, when we received it this time around, the condition was just severely degraded. The bronze was very eroded, and it would have required extensive repair that would have exceeded the cost of a new steel casing. So Hydro Rocky Mountain worked with Hydro Part Solutions in Texas to reverse engineer the casing, to fully scan it and get all the dimensions identical so that we can build a brand new casing from carbon steel.
When a part comes in, we don't have the data or the geometry on the part. So to get that to make the castings and to make the machined parts, we actually have to take the data off of the parts to reverse engineer it. So when you're reverse engineering a part, you want to try to bring it back to the original design intent of that part. The reason you want to do that is you don't want to make your customer a brand new worn out part. The pump itself is a pretty complex pump to even be poured out of cast iron, much less carbon steel. So to upgrade it, there were a few challenges involved with getting the solidification right for it too, because of the complex geometry. After we've reverse engineered the part, we add the machine stock to the part, add any of the foundry allowances and do simulations on it for the foundry, and then we would send that off to the foundry itself. From there, they would print the 3D cores that come from the 3D model itself, and they use rapid cast technology. It prints sand. And the sand cores would then be used in the molds to make the castings. When this part came back from the foundry to us, we sent it to the machine shop, and the machine shop then machined the part. They faced off the split line, bored the bore, and made sure every critical fit was machined correctly. Then that comes back to Hydro Part Solutions, where we then inspect the part, make sure that everything is correct, and then we shipped it.
This is a case where we were able to take one of the most critical pieces of infrastructure at the customer's plant and improve upon the weaknesses that they knew existed in this pump, and then deliver them a piece that will last them the rest of the existence of this plant.